Welcome to Python tutorial, lesson 29. Today we learn type hints for our code. Annotations catch bugs and improve clarity. Type hints add type information to variables and functions. Write a colon after the name, then the type, like str or int. An arrow marks the return type. Let us create basic hints.py with annotated variables and functions. We declare 4 variables with type annotations: str, int, float, and bool. The greet function takes a str parameter and returns a str using the arrow syntax. Add takes 2 ints and returns an int. IsAdult returns a bool. Hints tell callers what to pass. Log message returns none, meaning it performs an action without a return value. The results section shows that type hints do not change runtime behavior. Let us review the code with bat. Each function signature reads like a contract between the function and its callers. Now let us run the code and see the output. Python runs normally. Type hints are ignored at runtime and serve as documentation. They help developers and tools understand what types are expected. str and int are built in, but what about lists or optional values? The typing module adds list, dict, optional, and more. Type aliases name complex annotations for readability. Let us create typing module.py to explore complex type annotations. We import list, dict, optional, union, and tuple from the typing module. Average takes a list of floats and returns a float. The brackets specify the element type. Create profile returns a dict mapping str keys to union of str or int values. Optional means the return could be int or none for missing keys. Min-max returns a tuple of 2 ints. Tuples have fixed length and types. User profile is a type alias. It gives a short name to a complex dict annotation. Format profile uses the alias instead of repeating the full dict union type. The results section uses the annotated types for variables too, not just function signatures. Let us review the code. Each function clearly states its input and output types with no ambiguity. Let us run the code and check the output. Find Alice returns 25, but Find Charlie returns none. Optional documents this perfectly. Min-max returns a tuple of 1 and 5 from the list, matching the tuple annotation. Now let us build a fully typed mini project, a task manager. Every method, parameter, and return type gets a type annotation. We will also use mypy to verify our types are consistent. Let us build the task manager with full type annotations on every method. We import list, dict, and optional from typing for our class signatures. The task class annotates each attribute. Title is str, priority is int, done is bool. Complete returns none because it only changes state. Dunder repr returns astr. Task Manager stores a list of task objects. The annotation says exactly what the list holds. Add returns a task, so callers know they get back the created task object. Find returns optional task because the task might not exist. None is a valid result. Get pending returns a list of tasks. Summary returns a dict, mapping str keys to int counts. The results section also annotates local variables like mgr and found. Found uses optional task, so we check if found before calling complete. Let us review the complete file. Every method signature is self-documenting. A new developer can read the types and understand the API. Let us run the task manager. Three tasks are created, then send email is completed. The summary shows 1 done and 2 pending. Now let us run mypy to verify our type annotations are consistent. mypy confirms no issues found. Our types are all correct and consistent. Let us recap type hints. Annotations document variables, parameters, and returns. The typing module adds list, dict, and optional. Tools like mypy catch type errors before your code runs. Thanks for watching. Subscribe for more Python tutorials. In the next lesson, we cover file I/O.